Good morning, everybody, or good afternoon, or whatever time you're watching this. Today we're going to talk about how to graph with slope-intercept form. The main idea is that we're using this equation. It's called y equals mx plus b. It goes just like that. So this is something you're going to be using forever. This is like the 30 life code from Capcom back in the day. Or what's Capcom? From Contra. I'm trying to remember who made Contra. It's Konami, that's what it was. Anyway, it's an old school 80s video game reference if you get it. Yeah, this is the bread and butter. This is one of the old classics. So the M stands for the rate of change, also known as the slope. And the B stands for the y-intercept, or where this line crosses the y-axis, because this is a linear equation. It's going to cross, well, not necessarily going to cross the y-axis. There's some examples of ones that don't. Anyway, let's get right to it. So we have y equals 2/3 x minus 2. So this is going to be our m, and this is our b. So we always plot the y-intercept first. So -2 goes right here. The rate of change is 2/3. And remember, positive slopes, or positive rates of change, look like this. They go up from left to right. And negative rates of change go down from left to right. You always remember that. So 2/3, we're going to up 2 over 3, because remember, that's change in y over change in x, or vertical change over horizontal change. So we're going to go, we'll zoom in a little more here. We're going to go up 2 over 3, or right 3, and then up 2, right 3, and down 2, left 3, and down 2, left 3. And we're going to connect these. And that's definitely a positive rate of change, and there we go. That's it. All right. So our b here is -4. Y-intercept. Our rate of change is 6 over 5. So it's almost 1. 1, 5, 6, and then right 5. 1, 2, 3, 4, 5. We can't fit any more. I like to plot as many points as we can possibly fit. I don't know, it's a good habit, because if you make a mistake, you'll see it more readily. 5 is our y-intercept, 1/2, so up 1 over 2, down 1, left 2, down 1, left 2, down 1, left 2. Okay? Oh, totally off screen, I'm sorry. There we go. That's not very helpful, is it? Okay, and then we have -2 is our y-intercept, and 5/4, so 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Can I go down 5? I can't fit anymore, unfortunately. Okay, -3 is our y-intercept. -1 is our rate of change. So we're going down from left to right, as you can see. -1 is our y-intercept, 2/5, so up 2, right 5. Hey, Khaleesi. Down 2, left 5. 1, 2, 3. 1, 2, 3, 4, 5. There we go. Okay. Now the back side of this is interesting, because it's going to be equations that are not ready to graph. We actually have to do a little bit of legwork here. So these are not written in slope-intercept form. These are actually written in what we call standard form. Or, well, this one actually is not in standard form, but some of the other ones are. This is just whatever. I don't know what you'd call that. This is actually, this is almost in slope-intercept form. We just have to move it. This one's not that bad. So we're taking y equals 4 minus 5x. So we're just going to swap. We're going to move it, basically. So we're going to say y equals -5x plus 4. So we're just changing their location. And now we can graph that. So 4 is our y-intercept. -5, so it's -5 over 1, so down 5, 1, 2, 3, 4, 5, then over 1, and then 1, 2, 3, 4, 5 over 1. And that would be our line there. Okay, here, we're going to write 0 equals 6y minus 6 minus 2x. So we get y by itself, so we're going to subtract 6y, so -6y equals, I'm going to move this -2x in front so it starts to look like the format we want. Now we just divide everything by 6, or negative 6 rather. So we have y equals, let's see, positive 1/3 x, and then that's going to be positive 1. So our y-intercept is 1. Our rate of change is 1/3, so up 1 over 3, 1 over 3, and then down 1, left 3, down 1, left 3. There we go. I don't know if you guys can hear that, but there's a bird by the window, so Khaleesi's freaking out. It's pretty funny. Alright, let's get y by itself here. So I'm just actually going to subtract 5 from both sides. First I'll rewrite it over here. So 0 is equal to y plus 5. Let's subtract 5 from both sides. So y is equal to negative 5. Now this is what we call a special case scenario, because this is not going to be a traditional line. Well, not the traditional ones we're used to graphing. So if y is equal to negative 5, that means it's going to be a line that is horizontal because the y is not changing. So you'll see that y is always negative 5 along this line right here. And this has what we call zero slope. Okay. Undefined slope are lines that have a vertical look to it, the ones where the x does not change. This is where the y is constant. And then, excuse me, vertical lines are lines where the x is constant. Alright, so let's rewrite this. So 6y plus 2x equals negative 24. We want to get y by itself, so we'll start by moving this 2x to the other side. We're going to say 6y equals negative 2x minus 24. Divide everything by the coefficient, 6. Y equals negative 1/3 x minus 4. Now we graph that. So negative 4 is our y-intercept, and negative 1/3, so down 1 over 3. Down 1 over 3, then up 1, left 3, and up 1, left 3. There we go. There we go. Okay. And then here, let's rewrite this equation. 4x minus 5y equals 10. We're going to subtract 4x from both sides. Negative 5y equals negative 4x plus 10. Divide everything by the coefficient. Y equals 4/5 x minus 2. Negative 2 is our y-intercept. Our rate of change is 4/5, so we're going to go up 4 over 5. So 1, 2, 3, 4, then 1, 2, 3, 4, 5. Then down 2 left 5, sorry, down 4 left 5. So 1, 2, 3, 4, then 1, 2, 3, 4, 5. Like that. Here we go. Okay, last one. So I'm going to rewrite that. Actually, you know what we can do? This is like the number 7, actually. This is kind of funny. So we're just going to change it around. We're going to say y equals 3x plus 3. So we really didn't do much. Just kind of shifted the position here. So 3 is the y-intercept, and 3 over 1, so we're going to go up 3, 1, 2, 3 over 1, and down 3 left 1, 1, 2, 3 left 1, 1, 2, 3 left 1, and 1, 2, 3 left 1. There we go. Alright. And that is that. So hopefully that was helpful, guys. I'm going to try to do another video of the other worksheet before we're out of time today, before class starts. So if these are not helpful, if you're still confused, please let me know, and I'll definitely answer your questions. All right, thanks, guys.